Oh, thank you, Kat. I just want to say it's really wonderful to see so many familiar people here today. I'm really glad to be here. So for those of you who don't know me, I'm Andrew Ayer. Since 2016, I've operated a certificate transparency monitor called CertSpotter, and I've sent quite a few emails to the CT policy mailing list talking about various ways that certificate transparency logs aren't working right. And today, I'm going to talk about that. So why do we care about certificate transparency log failures? Well, anytime a CT log fails, it creates a risk that domain owners might not be notified about certificates for their domains, and it creates a risk that previously issued certificates might stop working. Now, thankfully, this has never happened during the history of CT, but this is pretty much just luck. If the wrong combination of logs fail, then previously issued certificates will stop working. So this is really something that we want to avoid. Now, here's a graph of CT log failures over the past 10 years. In red are what I'm calling the fatal failures. This is every time that a certificate transparency log had to be retired, but I am excluding cases where the log operator intentionally shut down their log. And then in blue, we have what I'm calling the non-fatal failures. These are serious incidents like having a multi-day outage or violating the MMD that did not lead to log retirement. And I'm including them because even though the log wasn't retired, these were really bad issues and they certainly could have led to the log being retired. And also, by the way, if a log operator had multiple logs fail at the same time for the same reason, I'm only counting that as one failure here. So in total, we've had 23 failures over 10 years, which means that on average, it's more than 2 failures per year. And I really think that number is too high. So let's look at all of these failures and see if there are any lessons that can be learned to hopefully prevent similar failures from occurring in the future. So here are all the ways that certificate transparency logs fail. The most common failure mode we've seen is unincorporated SCTs. This is where a log receives a certificate from a submitter. The log issues a signed certificate timestamp, promising to include the certificate in the log, but then it just never does so. Now, that's a really serious violation of transparency, so consequentially, every time this has happened, the log has been retired. So then the second most common failure mode is an MMD violation. This is where a log receives a certificate, it issues an SCT promising to include it, but then it fails to include that certificate within the 24-hour maximum merge delay deadline. Now, in these cases, the certificate does eventually end up in the log. So for that reason, there is some discretion available here, and it's possible for the log to continue operating once the certificate is in the log. And for that reason, all of these failures have actually been non-fatal. A log has never been retired purely for an MMD violation. And then equally common to that has been multi-day outages. And these are more severe than an MMD violation because not only are recently logged certificates inaccessible, but actually the entire log is inaccessible. And 3 of these have been fatal and the log has been retired, and 2 of these incidents have been non-fatal. And then after that, there have been 4 cases of a log signing an inconsistent tree head. And in this case, what happens, the log issues this tree head, but the log is unable to produce a sequence of entries which hash up to the hash that's in the tree head. And now, since a log is unable to take back an STH after it's signed it, these are always fatal errors that require the log to be retired. And then there's been one failure of the log operator just losing the data for the log. That, of course, is fatal. One case of an inconsistent entry. This is where the Merkle tree is fine, but there's an entry in the log that doesn't make sense. An example of this would be if a pre-certificate doesn't match the TBS certificate in the Merkle tree leaf. And this has happened once and it was fatal. And then there was one instance of private key compromise of the log, and that, of course, was fatal. So what I did was I looked at every one of those failures and I tried to identify a root cause for it. And at the top, tied for most common, was the use of asynchronous merging. This is the practice of a log returning a signed certificate timestamp for a certificate before that certificate has actually been merged into the log. Equally common has been the log using the wrong storage model. And then there were 4 failures where the log operator didn't provide a good enough incident report, so I wasn't able to figure out what really happened there. But interestingly, every one of those 4 failures was actually an unincorporated SCT. And I think that quite likely the root cause for those was also asynchronous merging, and I'll explain more in a moment. Then there were 2 cases where the log failed because configuring it was more fragile than it needed to be. There were 2 instances of cosmic rays, which is just a cheeky way of saying there were bit flips in the log and no one knows why. And then 1 case of the operator doing administration manually, 1 case of the log operator not having enough resources to operate a reliable log, and then there was 1 security compromise. I'm going to focus just on the first 4 here because they are the most common and they have some really great lessons to learn from. So, traditionally, the way that certificate transparency logs have worked is that someone submits a certificate and the log returns immediately a signed certificate timestamp promising that at some point in the future, hopefully, that certificate will be added to the log. And in the meantime, the log just sticks that certificate in some queue somewhere. And this has caused some problems. And the first problem this has caused is that it enables logs to accept certificates faster than they can be merged. And this is because issuing an SCT and adding a certificate to a queue is a fast, parallelizable operation. But actually processing these queues and merging these certificates into the log, that's slower and inherently sequential. So there have been 5 failures over the years where a log has been unable to merge all of the certificates that are pending into the log within the 24-hour MMD deadline. And in all these cases, basically the same thing happened. You know, a bunch of certificates, there's been a surge of certificates, submissions to the log, and the log just can't keep up. Then the other problem that asynchronous merging causes that logs can accept certificates, issue SCTs for them, and then just forget about them. And this has happened 5 times. And we only got a good incident report from the log operator in 1 of these cases. And what happened there was that the queue of these pending certificates was being stored in memory. So that meant that when the log software restarted, all of these pending unincorporated certificates were just lost. Now, we don't know exactly what happened in the other 4 cases, but what I find really interesting about them is that the log operator didn't have any trouble storing the log itself. It was just this queue of pending certificates that, for whatever reason, got lost. And that just leads me to believe that this practice of having this queue of unmerged certificates is just inherently risky. And it's a bit surprising to me because you would think that in theory, if a log operator can store the log successfully, they should be able to store this queue successfully, but that just hasn't seemed to be the case in practice. And for that reason, I think that logs should not return an SCT for a submitted certificate until a new tree head incorporating that certificate has been signed and stored successfully. This has a number of advantages. Now, there are some downsides also. It does mean that it takes a little bit longer to submit a certificate. You might have to wait a second to get an SCT back instead of like 100 milliseconds. But the advantages, I believe, are just enormous. Because first of all, it provides natural back pressure. It's just simply no longer possible for a log to accept certificates faster than they can be merged. And then second, it fails safely. Because let's say that some problem occurs when the log is signing and storing that tree head. Let's say, for instance, it's using file system for storage and the file system runs out of space. So with asynchronous merging, even if you're durably storing those pending certificates, if there's a problem creating a tree head, then the log operator now has this deadline that they have to meet to go in and figure out what went wrong, manually process this queue of pending certificates and make sure they get in the log. But with synchronous merging, what the log can do is it can just return an error to all of the pending certificate submission requests instead of an SCT. And then the submitter can go get SCTs from a different log. Chrome has recently issued guidance to log operators saying that if something's going wrong with your log, if you think there's a risk that you might not incorporate all your certificates, then you should put your log into read-only mode as soon as possible. And the nice thing about synchronous merging is that that basically happens automatically. If there's some problem publishing the tree head, the log just will stop, accepting entries. And then lastly, it's just simpler because now the log operator only has to worry about storing the log data durably. But with asynchronous merging, the log operator has to worry about both the log itself and this queue of pending certificates. So now let's talk about databases. Historically, certificate transparency logs have been built on databases like, say, MySQL or PostgreSQL. But I would argue that CT really doesn't need databases. If you think about what a transparency log is it's just this append-only, list where you're just adding stuff to the end. You're never updating, you're never deleting, and also you're mostly just retrieving, entries by their position in the log. So you don't need these features of databases. The other thing that databases are really good at is indexes. But certificate transparency logs don't really need indexes for basic read operations. So if you're operating an RFC 6962 log, you need two indexes. One, you need an index to prevent duplicate certificates from being added to the log. And second, you need an index to implement the getProofByHash endpoint, because this endpoint, it takes a leaf hash as an argument, and it has to be able to translate that leaf hash into an entry number. But just the basic getEntries call, which is the bulk of the read traffic to a log, you don't need an index for that, because it's just the numeric entry numbers. Now, static CT API, that does away with the getProofByHash endpoint, so you don't need an index for that. The only index you need is the duplicate prevention index. And the beautiful thing about the duplicate prevention index is that it's possible to lose some or even all of the entries in this index. Because the worst thing that can happen in that case is the log might accept some certificates that are already in there. So worst case scenario, you lose the entire duplicate prevention index, and your log doubles in size as every certificate gets submitted a second time to the log. And that's not ideal, but it's far, far better than losing the entire log. And then another thing too, which I realized, is that with Merkle tree certificates, where the certificate authority is the one operating the log, they don't even need the duplicate prevention index because they're the only one submitting to that log. You only need the duplicate prevention index if you have third parties potentially submitting to the log who might submit duplicates. So instead of databases, keep your log entries in immutable numbered tiles on the file system or in object storage like S3. And the tlog tile spec that's used by static CT API provides a great blueprint for doing that. And the beautiful thing about static CT API is that you can then just serve these tiles using just a regular web server. But even RFC 6962 logs, I would actually benefit from using the tile format internally instead of storing everything in a database. Because, well, databases cause problems, and one of the problems with databases is that there are more things that can go wrong with them, and recovery is harder. In 2017, a log operator had a failure of their database that required recovering the database from backups. What I find interesting about this failure is that the backups were stored in object storage, and the backups were complete. There was no data loss because of this incident. But because the log was being served out of a database, the backups had to be restored from object storage. This was a complicated process. The operator made a mistake in the process, and they signed an inconsistent tree head, killing the log. And then recovery can be slow. In 2022 and 2023, we saw a log operator have multi-day outages because the database they were using had to be restored from disk into memory every time the log server started. And so what would happen is if all of the nodes in their log cluster died at the same time, then they would have to wait for the database to be loaded back into memory. And since the log was huge at this point, these were multi-day outages. And then in 2023, we had an operator suffer a multi-week outage of 3 of their logs because they too had a failure which required restoring their database from backups. And this was a long and complex process for them. And then databases can have corruption. In 2024, a log operator ran out of disk space on the partition containing their MariaDB database. And MariaDB handled this very poorly. It actually corrupted the table containing all of the pending certificates. So this led to the log having unincorporated SCTs. And now, certainly not all not all database software is going to handle that out-of-space condition as poorly as MariaDB did. But this just goes to show if you're using a database, you better make sure you're absolutely certain of what your database's properties are and how it's going to handle these fairly common conditions like out-of-space errors. So another problem with databases is that it's hard to scale reads. Quite a few log operators have had problems with this over the years, and there have been a lot of frequent short outages because of log operators not being able to handle all the read load. And in 2025, there was a multi-day outage of 2 logs by the same operator because their database couldn't handle the read load. And what I find really telling is that 3 log operators now have tile-based caches in front of their database. The way that these work is that as clients are retrieving entries, these caches are basically creating tiles on the fly and storing them in object storage. It's not the exact same format that tlog tiles uses, but it's basically the same concept. And this solves the read scalability problem very well, but I find it to be an unfortunate architecture because ultimately the database is still there, and if there's a problem with the database, those tile-based caches are probably not going to save it. So my thoughts are, if you have object storage and you're making tiles anyways, that should be the source of truth for the log, not a database. So lastly, with databases, you have a problem of low limits. RDS, which is Amazon's MySQL service, has a per table limit of 16 terabytes. This has already killed a test log, and a production log is coming close to hitting that. PostgreSQL is a bit better with 32 terabytes, but that's still a limit that a log could conceivably hit, especially if signatures get larger, the certificate issuance gets more frequent. On the other hand, if you're storing on the file system or object storage, the limits there are basically infinite. And finally, configuration fragility. In 2016, a log operator used the same private key for their test and production logs, which led to the production of inconsistent STHs. In 2020, a log operator configured their test log to use their production etcd cluster. This made the log software very confused. Writes went to the wrong place, and inconsistent tree heads were signed for 2 of their logs, killing them. So it's certainly not possible for log software to prevent all mistakes an operator could conceivably make, but I think log software should try really hard. And I want to talk about Sunlight's global lock backend. Sunlight is Filippo's static CT API implementation, and I really love the global lock backend. What this is a small database that's shared amongst all of the logs operated by an operator. And this database, it maps log public key to the latest tree head signed by that public key. So when Sunlight needs to add some new entries to the log, it starts with a tree head. It then adds the hashes for all of those entries to that tree head, and then has a new tree head. And before publishing that tree head, Sunlight will do an atomic compare and swap, in the global lock backend. And if the tree head that was previously there for that log key is not the tree head that Sunlight started with, that means that Sunlight was about to sign an inconsistent tree head, so Sunlight will just abort the operation. And this plays very nicely with synchronous merging because it means that any pending certificate submission will just fail with an error. And then the log operator can go and figure out what went wrong and most likely recover the log successfully. And this is just wonderful because it means, the global lock backend means that as long as the log operator always uses the same lock backend for all their logs, Sunlight will never sign an inconsistent tree head, even if the operator reuses keys, and even if the operator accidentally starts multiple instances of Sunlight writing to the same place. And I think that's just wonderful. So, to sum up, my recommendations are: 1, logs should not return SCTs until a tree head is successfully signed and stored. And this means that if you're using Tesseract, you should not disable its publication awaiter. I think there's a bit of a misconception that static CT API forces logs to do synchronous merging, but in reality, it only forces synchronous sequencing. But it's still possible for static CT API logs to delay the publication of those checkpoints, and I think it's better, if static CT APIs did not do that, if they did it synchronously. And then second, store data in tiles on the file system or in object storage. And finally, log software should be as resilient as possible to config mistakes. And I think that Sunlight's global lock backend should be table stakes here. And I think that if logs had been following these recommendations, it would have prevented at least 12 and potentially up to 18 of these 23 failures I looked at. And I think that's great because I think this really sort of validates that the ecosystem is moving in a good direction with this new log software that we're making with the new T-log tiles spec. And I hope that that more logs, CT logs, will move towards using new log software with static CT API, and that will have a more robust ecosystem in the future. Thank you.
Thank you, Andrew. Do we have any questions for Andrew? I will bring you a microphone. Come on, yeah.
I suppose I'm already mic'd up, but I can use another mic. Yeah, so not really a question. I just want to say that right now, Twig, Let's Encrypt CT test log is currently having an outage because of the global lockend being down because of an Amazon outage. DynamoDB in US East 1 is currently down. So that's an exciting new failure mode caused by prevention of several other prevention modes.
Yeah. I'll just say to that, fortunately, that's should just be a read downtime, right? Sorry, a write downtime.
It is just a write downtime.
Yeah.
Also, we deliberately put the test log in US East 1 and not a production logs there because of Amazon's history of that region.
How many logs were considered here? Like, I know the failures, but how many didn't fail, I guess?
Oh gosh, that's a good question. There are a lot of logs because every log operator, we have, I guess, 6 or 7 log operators currently, I think. Yeah, and each one's operating like 4 or maybe even 6 shards currently because of it's sharded by year, and then we've had a bunch of years since then. So yeah, it's a long-winded way of saying it's a lot that haven't failed, but I don't know the exact number.
Anyone else? Hands up.
Have you noticed any trends in the failure modes over time?
Oh, in the failure modes. Yeah, I would say that recently there have been way more MMD violations and extensive outages, and I think the reason for that is because there's a mysterious person who's copying certificates from one log into other logs, and that has greatly increased the write load on logs, and they haven't responded so well. But apart from that, no, well, actually, yes, I would say that the unincorporated SCTs, we haven't seen those in a while. Those were mostly in the first few years of CT's history. But yeah, good question.
Okay, great. So with that, let's give Andrew another round of applause.